Okay, let's continue. In simple correlation, example, okay, the researcher commonly collects data into numerical or quantitative variables, okay, to see whether there is a relationship exists, okay, between these variable. So here we have cars and revenue for our variables, and we want to see whether cars have a relationship with the revenue. Okay, let's take a look at example two. The data shown below are the number of car owned and the revenue received for car rental companies in Malaysia for a recent year. Okay, so um, the variables that involved in this study is number of car owned and revenue received for car rental companies. Okay, make sure that when we ask you about what are the variables, you write it fully. Okay, just not car revenue. Okay, you have to explain. Okay, so this is number of car owned and this is revenue. And when you do the scatter plot, okay, scatter plot is actually is a graph. Okay, it's a graph that consists of your uh, commonly we put X as your IV and Y is as your DV. Okay, so this is uh, a scatter plot that consists of it is actually pair. Okay, this is pair. So when you plot this pair, you will get this particular scatter plot, and it consists of uh, it can explain it can explain the relationship between your variables. And when we take a look at this particular scatter plot, it seems that it have some sort of okay, this is just my estimated line. Okay, it has some sort of linear relationship, and it seems that it have a positive relationship. But uh, to do further analysis, we have to calculate the correlation coefficient. Okay, we have to calculate the correlation coefficient. Okay, so how do we do that? Okay, for correlation coefficient, okay, R, we have we have the formula. Okay, in previous slide we have in previous note we have formula which is R equals to okay SS xy over square root of SSXX times SSYY. So how do we get this particular value? Okay, when you refer to your formula, okay, so SSXY equals to okay summation of xy minus summation of x summation of y over n. While for your SSXX is actually okay summation of x square minus summation of x square over n, and you will have also here SSYY equals to summation of y square minus summation of y square over n. Okay, so for this particular example, you have to determine okay which one is your y, which one is your x. Okay, so based on scatter plot diagram here, your y means that your in variables in your y-axis is your revenue. So this is your y, and your x variable is your numbers of cars owned. Okay, so this is your okay, so this is your right. So how do we get this particular value? You can either manually calculated. Okay, summation of xy. So means that you this x times y, you time, and then you times. Okay, so if you total this, you get the summation of x. If you total this, you get the summation of y. Okay, if you times x and y, okay, to y2, and then you add, you will get summation of xy. Okay, so that's if you want to do manual calculation, but you can always use your scientific calculator to get this particular value. Okay, for example, okay, mode statistic, a plus b. I have pay variables. Okay, so we input what is our x, what is our y. So 63, 29. We put x first. 0.8, 0.1, 0.4, 0.5. And then we put our y, 7, 3.9, 2.1, 2.8, 1.4. Okay, so when you put the data like this, okay, what you can do is shift, stack, and then two variable calculate. All right, and this is basically okay, our our calculation for each. Okay, your summation of x, summation of y, and so on and so on. So what you do is you just okay copy the value. Okay, so summation of xy equals to summation of xy equals to okay 682.77. Summation of x equals to 153.8. Okay, summation of y equals to 18.7. Okay, summation of x squared equals to 5859.26. Summation of y squared equals to 80.67. Okay, so list all the value for the summation first, and then you transfer it into the formula. All right, so let's calculate r. Let's do calculate r. Okay, now I want to add this line. Oh, okay. All right. Okay, so r equals to summation x. So r equals to SSXY over square root SSXX SSYY. Okay, let's calculate the SSXY first. Okay, SSXY summation of XY minus summation of X summation of Y over N equals to 682.77 minus 153.8 times 18.7 over 6. Okay, you will get okay 4277. And then you calculate the SXSX. SXSX is summation of x square minus summation of x square n, right? 9.26 minus 153.8. Okay, and you will get this value. Okay, and then you calculate the SSYY, summation of y square minus summation of y square over n. Okay, make sure you don't confuse summation of y square and summation y square. 7 minus 180.7 square over 6. You will get to 2.3883. Okay, now for the last part, you calculate the R. Okay, 203.4267 over square root of 1916.8533 times the to 2.3883. Okay, and when you do the calculation, you will get the value of 0.982. Okay, so this is your R. Okay, for your R, you have to explain. When you explain the correlation coefficient, okay, you have to explain your correlation coefficient. Okay, first you can determine the magnitude. Sorry, the type of relationship. Type of relationship with whether it is a positive or uh, negative, and you can also uh, explain the magnitude. Okay, for this particular magnitude, you can use this cut off, strong, moderate, weak. Okay, so for moderate, we will use value 0.3, 0.7, and this is more than 0.7, and this is less than 0.3. Okay, so for this particular R value, okay, 0.982, okay, R equals to 0.982. It means that, okay, so magnitude strong, moderate, or weak. So since that the value is 0.9, it is belong to strong. Okay, so we say that there is a strong. Okay, negative or positive, your value is positive, so strong positive. Okay, strong positive. Linear relationship. Okay, between the number of car. Okay, number of car. So they have unit in 10,000 unit, and the revenue. And the revenue in millions. So this is example 2. Okay, how uh okay, how you write the explanation of your correlation coefficient. Okay, so you have to provide us with two. Okay, one is the magnitude. Okay, whether it is strong, moderate, or weak. Okay, strong, and the other one is the type. Okay, whether it's a positive or linear. Okay, depending on your value. Okay, your correlation coefficient value. Right? Okay, now for this particular example, I will leave it as your exercise. Okay, please do this example to test whether you understand, okay, how you can calculate the correlation coefficient by using the formula. Okay, right. So I will end our my video here. So if you have any question, you can ask me. All right. Okay. So thank you for listening. Bye.